Let's now take a look at trig integrals. So all the different sorts of trig integrals we've seen so far. So the basic ones, we know that when we integrate sine we get minus cos. When we integrate cos we get sine. Sec squared goes to tan x. So they were the three basic ones. Tan x we could do by a transformation sine x over cos x. I now have derivative over the function, well almost. The derivative of cos is of course minus sine x. So I'll get minus the log of cos, or if you want to bring that negative sign into the log, we get the log of sec. Now, this is one of these non-standard integrals. It's not on the sheet, but it's certainly well worth remembering because it does come up a bit, the integral of tan. So we know the integral of tan is log of sec, or minus log cos, whichever you prefer. This one here, integral of sec tan, we used to see it a lot when the topic of conics was around because it came up a lot in the calculations for conics. But anyway, the integral of sec tan is sec. That's another one that could be useful remembering. Now let's talk about complementary ratios then. The general idea is this: if you have to integrate a complementary trig ratio, then its answer will be minus the complement of the answer of the original function that wasn't the complement. So the complementary to sine is cosine. We know that when we integrated sine, we got minus cosine. So the answer to this one will be minus the complement. Minus, minus, and the complement of cos is sine. Now I'm not suggesting you remember that this way, but that pattern happens for all of them. So if I had to integrate cosec squared, well I know that when I integrate sec squared I get tan. Therefore, when I integrate cosec squared I must get minus cotan. Cot, which we just said, hey, we can remember tan is the log of sec or minus the log of cos. Well, cot is the complement of tan, therefore the answer will be the minus the complement of the answer for the tan. So we get, instead of minus the log, we've just got log, and instead of cos, we've got sine. Cosec cot, well, we just said that sec tan went to sec, therefore cosec cot goes to minus cosec. So what I'm getting at, here's tan. Tan was the log of sec, which means cotan, right? Cotan is the complement of tan. So the answer is minus, and the complement of sec is cosec. So I could have written that as minus the log of cosec, which is the same as the log of sine, of course. That's the idea with complementary ratio. Squares of trig functions then. Sine squared, well, we saw we could use our double angle result, and that will turn into a half of 1 minus cos 2x, and then we can integrate that, and we get x on 2 minus a quarter sine 2x. And cos squared, very similar, but it's 1 plus cos 2x. Of course, if you wanted to, you could use double angles on the sine 2x and change that to sine x, so you get a half of sine x cos x. In each of those. Sec squared, well that's a standard one, so that goes to tan, which means cosec squared, as we just said, goes to minus cot. Tan squared, well I could use a trig identity, that's sec squared minus 1, so it will become tan x minus x, which means cot squared should end up with minus cot. Now notice the x doesn't change sign, because that's not a trig ratio. It's the trig ratio that changes the sign. So we get minus cot minus x for that one. Cos squared of 3x. Okay, I'll use my double angle result. I get a half of 1 plus cos 6x, and that I can integrate quite easily. Sine x cos 2x. Ooh, be nice if that was cos x, because sine x cos x, there would have been a couple of ways I could do that. I could look at it and say, oh look, I got derivative times function, or I could change sine x cos x into sine 2x, but the angles aren't the same with this one. So here's where I'll use products to sum. So that'll be a half the sine, the sum, and 2x plus x is 3x, plus the sine of the difference. And remember, when we're talking about the difference, it's important that the sign is first, because it'll be x minus 2x, and sine being an odd function, then that becomes minus sine x when we integrate on that one. Minus cos 3x on 6 plus cos x on 2. Sine x cos cubed. Well, this one is in that form of derivative times function to the power of 3 in this case, but the derivative of cos x is not sine x, it's minus sine x. So really what I'm looking at is that, minus the integral of minus sine x cos cubed. I've now got it in that form of some function to the power. So we just add 1 to the power over the power, and substituting in, we get our answer. Notice, by the way, I got rid of the negative sign in the front of the integral and swapped the limits around. Yeah, a couple of quick ones for today.